Good morning, everyone. I am Mohammad Sadiq from the Department of Artificial Intelligence and Machine Learning in Savita Engineering. Today, I am going to present my mini project titled Nexus Git, an AI-powered code review and collaborative platform under the guidance of my mentor Sarah Wilson, Assistant Professor, SG, Department of AI. In this presentation, I will explain the introduction of the project, the problem statement, scope, methodology, system design, implementation, output test cases, results, conclusion, and future works. In modern software, development projects are becoming more complex and highly collaborative. All through version control systems like Git build, manage code changes, manual code reviews are still widely used. These reviews are time consuming, inconsistent, and sometimes fail to detect bugs or security issues. Nexus Git is designed to solve this problem by integrating AI powered automatic code review directly into the version control workflow. The problem statement. The main challenge in the traditional code review are manual reviews take a lot of time. Different reviewers give different opinions. Small teams lack expertise reviews. So the objective of this project is to build a Git-like platform that uses AI automatically analyze code during pull requests and provide intelligent suggestions. Scope of the project. The scope of Nexus Git includes repository creation, commit branches, and pull requests AI-based static code analysis. The target audience includes students, developers, and software teams. Advanced features like full CI/CD automations are not included in the initial phase. Data and methodology. First, source repositories are collected and processed. The AI-based static analysis model analyzes the code without it executing it. The web application is developing using microservices to manage a repository and pull requests. Finally, AI review. Finally, AI review results are integrated and tested within the system. Architecture design. The architecture design shows the flow between workspaces, static area, local repository, and remote repository. When a developer commits and pushes code, it triggers the AI review during pull request. Design and use cases. The use case diagram shows two actors, developers and admin. Developer can push code, create pull requests, AI reviews, and collaborate. Admin manages users reviews and system analytics. Class diagram. Request entity searches, user repository pull request, and the AI review. These classes define the structured behavior of the system in object-oriented manner. Sequence diagrams. This sequence diagram shows how code from developer to repository, how pull requests are created, and how AI reviews and human comments are generated. Algorithm using. The project mainly uses static code analysis algorithm, which analyzes code without executing it. Additionally, an AI-based recommendation model helps in practicing risky code and assigning relevant reviewers. Hardware and software using. The backend is built using Spring Boot microservices. AI services use Python, and the front end is well-based. MongoDB is used for storing repository and pull request data. Implementation. The system analysis code submitted through the commits and pull requests. AI categorizes issue searches, performance maintainability, and security problem, and displays suggestion directly inside the pull request interface. Important code segment. This slide shows important backend code segments related to repository handling, pull request creation, AI requests, and emerging. The code is implemented using Spring MVC architecture. Outputs means first the login page is displayed. New users can register and exhibiting users can log in. After login, dashboards into repository and pull request. Developers can request AI view or view existing AI suggestion. This is registration page allows new developer to create an account. This test case is validated. User registration, login, pull request creation, and AI functionality. Expected outputs are come with results to verify system correctness. Results. The AI smart review achieved accuracy of 91%, precision 88%, recall of 86%. This results in cleaner, merge, and faster reviews. Conclusion. Nexus Git provides that early AI feedback significantly improves code quality and stability. By periodically using this code section, developer can merge with code more confident. Future work. In the future work, system enhanced using code embedding, review commands, discussion threads. This will improve bug prediction and solutions. References. The project is based on the research paper, books, and GitHub documentation. The project GitHub link and demo videos are also provided. Thanking you. Next, next we are move on to our working model of the project. Now, first, this is an architecture of our project, system architecture. Unlike a traditional monolith app where everything is one big block, we use a microservice architecture. User service port 8081 handles the registration or login security. Repository service port 8080 handles the dashboard file uploads and code storage. Dash databases. We use MongoDB, NoSQL, since source code files vary in size and type. A document-based database is much faster and more flexible than SQL type. Key features. We completed the fluid CR, create, read, update, and delete cycle, security authentication, repository management, file IO operation, code viewers. For backend, we use Spring Boot for rapid microservices. Database MongoDB Atlas cloud-based NoSQL storage. Frontend team life server side frontend tools IntelliJ, ID, Maven dependency management. Challenges and solutions. Later on challenges, we move on to the working principles of this project. First of all, as we stayed in the system architecture, we use two servers on the ports. One is user authentication first. Oh, another one is a repository service management. We are currently running two responses. First, we need to stop all the responses. First of all, we will run any response. If any bugs are there, we can use one login pages. If either a problem in repository, we can run login pages as usual. If login page is problem, we can run repository either. So this is the microservice. So we can run simultaneously on the two projects. Next, user authentication process. So we're currently running two applications. This screen dot signaling, we can able to run these two applications in the so in this is the login page of our model. In this login page, we can create any type username. Or else we can create an account means we can create demo user and email ID and passwords. We have already account means we say we have already account and we enter the username and password and we log in. This is directed to the dashboard of our project. This is our dashboard of the project. We can add new repository or we can able to view the existing repository. If we need to add the repository, we can simply give some uh, name and descriptions, and we can upload any of the following details. As far I upload with .java extension a color coding program, we can choose and start and create repository. It will create our repository with name and the description. We can view the name. We can view the repository by clicking it. We can see. We enter into the another dashboard. We can see the project name with descriptions. And also you can able to the delete repository button. And the files inside contains the coloring.java file. If you click the coloring.java file, it will load it. It's simply not in text based. This also implement with color coding. So enable the user more user friendly reading coding. We can return to the repository or we can able to download. It will download straight to the our desktop. But we can return to the repository by clicking this. If we need to delete this repository means we can simply delete repository and okay. It will gone entirely now. Afterwards we can sign out means we can sign out. This is our working model repository.